Okay, so welcome back. I'm just going to do this example where, or not this video, where I show you some examples of curves that are symmetric with respect to the different axes or the pole. So the three different ones in the last example. So again, so we could have a graph like this. Again, my graphs, my artistic skill notwithstanding, you can see that this is going to have symmetry with respect to the polar axis, right? The polar axis, because again, this is an example of what it would look like. So we have this this cardioid, and so you can see that it's symmetric with respect to the polar axis because you flip it down. This would be an example of something that's symmetric with respect to the pole, right? And this would be an example of a curve that is symmetric with respect to the line pi over theta equals pi over 2, okay? Which again represents the y-axis, in other words. So the polar axis is the positive x-axis. The line theta equals pi over 2 is the positive y-axis, right? And so the pole is the same at the origin. So we see all the different types of symmetry that we're used to seeing, but now we're looking at it from the context of a polar curve in the polar coordinate system. Okay, so in the next video I'm going to start doing some examples of testing symmetry without drawing the curve. Okay, because we can view the curve and we can see that it has each one of these types of symmetry. But what if you want to do it algebraically? That's what we're going to do next. Okay, see you then.